To use pesticides successfully, you must apply the correct amount over the target plant or area uniformly. Mistakes in the amount of pesticide or uneven application may waste money, fail to control pests, damage the environment, harm plants, and/or result in fines for illegal application. In every situation, you should know, rather than guess, whether or not you are applying the correct amount of pesticide. I'm Dr. DeBusk, and this video discusses calculating equipment calibration. Calibration means 1. How you measure pesticide and fertilizer output, and 2. How you adjust your equipment so it applies the right amount to the target area. There is no substitute for having properly calibrated equipment. Whether you want to control a pest better, have a healthy landscape, save money, prevent off-site damage, or reduce customer complaints, investing time in calibrating equipment always pays significant dividends. Precise application of pesticides and fertilizers allows the product to function as intended. If you apply too little or too much product, it can seriously affect performance and have consequences that customers readily see. An improperly calibrated herbicide applicator can result in poor weed control. Not applying enough fertilizer can lead to plants that lack color and are unhealthy. At the other end of the spectrum, you can injure desirable ornamental plants if you apply more herbicide or fertilizer than the product label allows. In such cases, improper calibration means you could be violating the pesticide label. Customers are not the only ones who see the results of poor applications. Every trip your employees make to deal with an application complaint is a trip and application that is not billable. The cost of labor, equipment, and fuel make such complementary applications expensive. The loss in dollars might seem insignificant on one landscape, but multiply that by the number of landscapes you service and the number of rounds you make to each one, and you're talking about a significant sum of money. Profits increase when there are fewer callbacks. It might be a subtle point, but improperly calibrated equipment leads to quality issues which customers, clients, or supervisors will notice. When pests are not controlled or plants look unhealthy, customers question the value of the service. Your truck and the application posting notice you leave behind advertise the quality of your work. The methods described here are practical, easy to learn, and require only basic tools. Before you begin, check to see that all equipment parts are clean and in proper working order. Every time you calibrate a piece of equipment, write down the settings, rates, and operating conditions. Frequent calibration is extremely important with liquid pesticides because the flow rate can change. Following an application, equipment will have pesticide residues. Because of the residue, you should wear protective gear as required by the product label. If you will be mixing the pesticide with water, you can calibrate with water. What if the pesticide is granular or is mixed with something other than water, such as fertilizer? Use the actual pesticide or mixture for testing the calibration. Always wear the recommended protective equipment when you work with pesticides. Compressed air sprayers range in capacity from small handheld bottles to backpacks, generally holding a volume of 2 to 3 gallons. Applying the correct amount using compressed air sprayers works through several principles: calibrating by area, calibrating by volume, and determining percent solutions. Depending upon the application objective, any one of these may be suitable. This can work for treating small areas, but it is not recommended for large areas because of application volume and coverage variability. Here are the basic steps of an example to treat an area of 250 square feet at the labeled rate of 5 ounces product per 1,000 square feet. 1. Pour 1 gallon of plain water into the tank and pump the sprayer to capacity. 2. While standing still on dry pavement, hold your arm extended while moving the spray wand back and forth just as you would while spraying the target site. Measure the width of the area that received the spray. The width of the sprayed area on the pavement is 4 feet. 3. Spray the pavement, moving in a straight line and maintaining the 4-foot swath width for 15 seconds. Measure the length of the strip covered in 15 seconds. The length of the covered strip is 25 feet. 4. Determine the total area covered by multiplying the width of the strip by the length. 4 feet times 25 feet equals 100 square feet. 5. Spray plain water into a bucket for 15 seconds, then measure the volume of water collected, 64 ounces or 0.5 gallons. 6. Determine the volume of water required to treat the area by first dividing the total area needing treatment by the square footage calculated in step 4. 250 square feet divided by 150 square feet equals 2.5. 7. Determine the total amount of water required by multiplying the number from step 6 by the amount of water collected in step 5. 2.5 times 0.5 gallons equals 1.25 gallons water required. 8. Determine the amount of product needed to treat the area by first dividing the area to be treated by 1,000 square feet, since the labeled rate is stated per 1,000 square feet. 250 square feet divided by 150 square feet equals 0.25. 9. Finally, multiply the labeled rate of the product required per 1,000 square feet times the number determined in step 8. 5 ounces times 0.25 equals 1.25 ounces of product to treat 250 square feet. A similar method works for calibrating the sprayer to treat particular plants or small groups of plants. In this situation, however, you calculate how much water you use to treat an average plant. If the label states spray to wet, spray as if you were painting this plant with spray paint. Try to avoid applying too much spray to limit the pesticide from dripping off the plant. Add water without any pesticide to the tank. Pressurize the tank, then record the number of seconds it takes to spray the plant completely. Now spray water into a container for that length of time. Use this number to determine the amount of water and product needed. You have a plant bed containing 18 azalea shrubs to treat. The labeled rate of insecticide is 3 ounces per gallon of water. 1. Select a single representative plant or group of plants, 1 azalea. 2. Add plain water to the tank and pump it to capacity. Do not add the pesticide product at this time. Adjust the hollow cone nozzle to deliver a fine spray. Small droplets are less apt to roll off the leaf surface. 3. Apply the water so that all parts of the azalea are covered uniformly. Be sure to treat the underside of the leaves as well as the upper side. Record the amount of time required to achieve adequate coverage, 12 seconds. Spray plain water into a bucket for the amount of time recorded in the previous step. Measure and record the amount of water in the bucket, 10 ounces of water. 5. Determine the amount of product needed to treat the group of azaleas. If 10 ounces will treat a single azalea, then 180 ounces of spray mix will treat all 18 azaleas. Convert to gallons. 180 ounces divided by 128 ounces per gallon equals 1.4 gallons of total spray mix. Label rate is 3 ounces of product per gallon of water. 1.4 gallons times 3 ounces equals 4.2 ounces of product needed. In some situations, calibration may not be necessary. Many ornamental plant pesticides applied as spot treatments are mixed with water at a particular percent solution as directed by the product label. Some product labels will contain tables listing the amount of product to mix with various volumes of water to achieve desired percentage solutions. If the label does not list this information, to make this solution, convert the pesticide's percentage of concentrate into a decimal before you calculate the amount of concentrate to mix with water. Do this by dividing the percentage number by 100 to get the decimal. This is the same as moving the decimal point 2 places to the left and adding zeros as needed. You want to spot treat patches of weeds growing in plant beds using a non-selective herbicide. The product label calls for a 2% solution. You wish to fill a 3-gallon backpack to capacity. How much herbicide should be added to accomplish this? 1. Convert 2% to a decimal. 2 divided by 100 equals 0.02. 2. Determine the number of ounces of herbicide needed per gallon of water. 0.02 times 128 ounces per gallon water equals 2.6 ounces. 3. Determine the total amount needed to mix with 3 gallons of water. 2.6 ounces times 3 gallons equals 7.8 ounces. 4. Mix a little less than 8 ounces of herbicide with slightly less than 3 gallons of water. There are some situations, such as spot treating very small areas or individual plants, where a small handheld bottle is convenient and useful. There is less potential for wasting material due to the need for mixing only a very small volume, such as 16 ounces. The same principles regarding percent solutions using decimal equivalencies apply whether mixing 3 gallons or 16 ounces. When mixing such small volumes, a useful conversion factor to know is that 1 fluid ounce equals 29.6 milliliters. For precise measurement of such minute volumes when mixing, a small graduated cylinder marked in milliliter increments is useful. Most granular product labels contain some recommended settings for common application equipment. However, these settings are only starting points. To obtain the correct dose, you need to calibrate the spreader. Spreader calibration is essentially a very simple process. 1. Measure the width of spread. 2. Apply the granules to a small area. 3. Measure the amount applied to this area. 4. Compare this amount to the desired dose and adjust the spreader settings until the desired output is obtained. However, in practice, this is easier said than done. In this section, the steps required to determine the effective swath width and application rate are discussed. Both your walking speed and the speed at which you turn the spreader handle will influence the rate at which the product is applied. A consistent speed will help maintain a uniform application rate and distribution. To determine walking speed, measure a distance of 100 feet. Using a stopwatch, determine how many seconds it takes to walk 100 feet. Most spreader manufacturers recommend walking about 2 to 3 miles per hour. At 3 miles per hour, it takes about 23 seconds to walk 100 feet. At 2 miles per hour pace, requires about 34 seconds per 100 feet. For handle cranking speed, turn the spreader crank at the consistent speed that is easy to maintain, generally 1 rotation per second. Granular spreaders do not distribute the same amount of material across the width of the treated area. More granules are deposited directly in front of the applicator than at the edges. Consequently, the applicator will have to overlap each pass when applying granular products. For this reason, you need to know the effective swath width. The effective swath width will be narrower than the entire width of the spreader throw. To do this, you need the granular product that you will be applying, 7 to 9 containers such as trays or shallow boxes, measuring tape, a small scale capable of weighing 1 gram, a stopwatch, numbered bags or jars to hold the granules, personal protective equipment required by the granular product label. 1. Set out the catch boxes or trays 2 feet apart on center, perpendicular to the direction you will be walking. Place the boxes on flat, dry, and empty plant beds covered with landscaping fabric or plastic. 2. Mark a starting point about 20 feet in front of the center box. Mark a point along your walking path to open the hopper at least 12 feet in front of the center box. 3. Practice walking toward the boxes at a consistent pace, using a steady handle cranking speed and stepping over the center box. 4. Fill the spreader at least half full. 5. Set the spreader's rudder to the center position or just right of center. 6. Adjust the spreader to the granular pesticide manufacturer's recommended output setting and spread the granules while walking toward and over the boxes. Open the hopper at least 12 feet in front of the center box and always walk towards the boxes in the same direction. Keep the hopper open until just past the collection boxes. Repeat the process at least 2 more times. When spreading, start turning the handle before you open the spreader hopper and continue turning the handle after closing the hopper until no more granules spread out. This helps keep the spreader from jamming. 7. Weigh the granules collected in each box. 8. Weigh the granules collected in the center box. Divide the number by 2 and find the collection boxes on either side of center that have about half as much product as the center box. The distance between the 2 boxes is the effective swath width. In this example, 2.4 grams were collected in the center box. Half the amount would be 1.2 grams. Box 4 on the right of center contained this amount, 1.2 grams. On the left side, the area to receive 1.2 grams of material would be about halfway between boxes 2 and 4 feet left of center. You would conclude that the effective swath width would be from about 3 feet left of center to 4 feet right of center, or 7 feet wide. This is the width that will be used in the next step determining the application rate. If you don't have a scale, you may want to consider an alternative method that is not as precise as the first method for determining effective swath width. This approach uses the first 6 steps as previously described, but visually evaluates the amount of granules seen in clear tubes or pill bottles. After completing the first 6 steps, label the tubes to correspond to the collection boxes. Dump the granules from each collection box into its corresponding tube. Locate the tubes with about half as much product in them to either side of center. The distance between these collection boxes is an appropriate effective swath width. Trays and collection boxes are useful for collecting granules when determining effective swath width. However, research has shown that they are not a reliable tool for calculating the application rate. Instead, it is better to weigh the amount of granules applied to a known area and then adjust the spreader settings to obtain the desired dose. To determine the application rate, 1. Fill the hopper on the spreader at least 3/4 full of product. 2. Weigh the filled spreader and record the weight. 3. Operate the spreader over a known distance at least 25 feet. 4. Reweigh the spreader and subtract the current weight from the original weight to determine the amount of granular product applied to the test site. 5. Calculate the area covered, the distance the granules were spread multiplied by the swath width of the spreader. 6. Calculate the application rate by dividing the granule weight by the square feet of the area covered. 7. Adjust the spreader output setting or your walking speed until your application rate is within 10% of the labeled rate. You want to apply a pre-emergence herbicide to ornamental plant beds at a rate of 3 pounds per 1,000 square feet. In making a test application, you spread 8 ounces of granules over a 210 square foot area. Is this spreader properly set to apply the target rate? 1. Convert the number of ounces in 3 pounds. 3 pounds times 16 ounces per pound equals 48 ounces of granules needed per 1,000 square feet. 2. Determine if the amount spread in the test application is equivalent to the target rate of 48 ounces. 1,000 square feet divided by 210 square feet times 8 ounces equals 38 ounces of granule product. 3. Determine the acceptable output range to be within 10% of the label rate. 0.10 times 48 ounces per 1,000 square feet equals plus or minus 4.8 ounces. 5 ounces for practical purposes. An acceptable range would be 43 and 53 ounces per 1,000 square feet. 4. This test rate of 38 ounces is more than 10% below the target rate of 48 ounces per 1,000 square feet. Adjust the spreader settings or slow your walking speed to allow more output and repeat the process until the rate falls within the acceptable range. I hope this gave you a better idea on how to calibrate your equipment. This was a lot of math, but it gets easier once you practice it in the field.